Okay, so good evening. How's everybody? All good? All settled? Unclear? Unsure? Here's what I know, and I think that you all know about that, but I'm just going to mention. So next week, we don't have anything, neither face-to-face nor online. So it will give the chance for the college to get a strategy in place, and then the following 2 weeks. So next week will not be around, and then the following 2 weeks we're gonna do online. How exactly that will be done, it's up to be decided yet.
2 weeks?
Yes, that's what I know. So
Next week?
So next week is off. Completely. There is no face-to-face, nor online. And then the following 2 weeks, it's online. Okay? I'll mention this again once we have more people. More people will come, and I don't want to be repeating that. So in our second half, I'll mention this again. Okay? But again, just keep in mind that I will talk about that. And also about assignments and what will be done with them. So all of that, I'll mention that. Okay? So today, we're going to be looking at those 3 things. We're going to be talking about exceptions. Again, we're going to be reconnecting with exceptions, more from exercise standpoint. We have started exceptions exercise last week. We're going to continue during our first half today. So we're going to be doing the next exercises of exceptions. I'll be demonstrating exceptions as well. So that will take us about halfway through our class today. Then in our second half, we're going to be talking about graphical user interfaces. And finally, our quiz number 4. Here, we're going to do, at the end of our first segment, we're going to be doing some practice exercises, practice quizzes that will help you with quiz 4, okay? But yeah, that's the idea, okay? Any question about the agenda of today? Anything? Okay. Great, so we covered exceptions last class. Last class we have discussed about, so on week 8, we have covered exercise 1, and I demonstrated that exercise. I'm going to do the same with, we're going to do the same with exercise 2, so I'll give you time for exercise 2. If you have done exercise 2 already, great. Keep doing the other ones. Keep moving forward. If you have not, then you're going to have a chance to do that. And in case you have done all exercises, you may want to work on your assignments, okay? Again, lots of options there. Hopefully not to keep you bored, or not too much at least. Okay, so to help you with exercise 2, you may want to consider looking at some links available under week 8. So on week 8, we have those links. This one in particular will be useful. It will show you how to throw an exception. Exceptions cannot just happen naturally. It can happen naturally, but they can happen by design. We may want to throw an exception at some point in time, and you can check this link to see how you can use the throw keyword properly, okay? Great. So we can get started. As usual, I'll be around, I'll be walking around, I'll be helping if you need some help there. But go through exercise 2, give it a try. I'll give you a few minutes to give it a try, and then I'll demonstrate this one. Okay? Yep. And then we're going to do some quizzes here to practice for later. Okay? Any questions? I will keep Padlet open in case you have a question there. You can always approach me as well.
Eu acho que na semana. Na outra semana. Na próxima semana, eu queria postar. Não, não, não está certo. Qualquer coisa, estava mandando qualquer coisa para terminar. E depois ia acertar. Ela colaborativa pública.
we have to take the input from user.
Yes.
The temperature.
Yep. And then we have to continuously ask. So we don't ask just once, we keep asking. And then for each time we ask, we evaluate if the temperature is comfortable, not comfortable, or invalid.
Comfortable is not comfortable. Invalid is we.
The exception.
Yeah.
Yes.
वो तो मांगते हैं एकदम आप सबमिट हो टेंशन मैंने अपना ये हो गया एक्सीडेंट
Yep. Squeeze it here. That's fine. That's fine. That's all.
Should not validate user input inside the set acceptor.
Should not validate input. Yeah, the validation should be done outside of. I think that's. Let me see here. This might have been just a note. I'm not sure. I don't think that I took any points because of that. It was just a note that, as best practice, you don't do validation of the user inputs. User inputs, leave it outside the class, like in the main. But the get and set should not expect to ask the user. See, the idea of object-oriented programming is that you keep things very separate. You have in one place you capture user information, whatever the user types. In another place you use that. So when you mix inside of a get, asking for user information, for the user input, I'm trying to see if I can run a comparison here.
So what we did, I think, so I think I have the code. So what we did was, so for example, so for example, like there's a name, and the name cannot have, for example, let's say it cannot be 6 characters long. It has to be a minimum of 7 characters. It's a minimum of 7 characters. So we set that in the set accessor, that if there is something which is less than 7 characters, then it is not valid.
It's not valid. Okay, that's okay. You can throw an exception there. You can actually, the best thing that you could do is in the set accessor, you check the size and you throw an exception. But don't ask the user. Don't ask the user for user input inside the set accessor. And I'm trying to, again, give a comparison here, but I'm finding a hard time. When you do that, you are mixing what should be this clean and clear class that should just receive information from somewhere. Okay, so I think I have a good point here. What if you want to use the same class in a web application? You cannot ask you cannot write console inside. So by writing the console inside of a class, you are connecting that class too closely with the console application. The class is no longer very independent, but go ahead, you were saying?
But I understand
Okay.
your point, what you're trying to say. But if we don't follow that, then I think we need to maybe make it Boolean. So the class maybe sends us true or false or something related.
So that's where the exception comes in. Because if we throw an exception, it's like we are saying, hey, we don't accept this. I'm going to throw in error. I'm so bad in this class that I'm going to throw in error if I told you that it's supposed to be, let's say, 6 characters. But you send me something bigger than that. I'm going to throw an exception here. And now I'm going to let you handle that. I'm going to tell you what the problem is. I'm going to give the message that says, hey, you have, I don't know how many characters. But that's the problem. Whoever called me will have to deal with that. I don't know what to do with that. I'm just telling you, it's wrong what you sent to me. Send me the right thing.
So do we need to send exception in that case?
Exceptions, you don't send exceptions. You throw an exception. So you see the exercise 2? I'm asking to throw that exception. So you don't send exceptions, you just throw them. When you throw an exception, everything is taken care of. Someone up in the chain needs to put that call inside a try. But your job as a class is just to say, this is good input or this is bad input. If it's bad input, I don't care how you send it, just send to me. But it's not my responsibility as the class to say, oh, I'm gonna ask to the console to get another value. No, it's not my job. My job is very simple. I just get a value. No matter if you are sending this via a web API, via a web application, via a console application, via a Windows application, no matter what. My job as a very independent class that I am, is just to get the value and validate that value.
Okay. like to get the syntax maybe. So for example, we have this set accessor. So we have set here.
Yep.
And it will throw the exception.
Yep. You do a check.
Try catch. So we do.
No. Just a throw. Try catch. Try catch should be wherever you are setting this property. Usually in the main, in our examples here, main will be the one setting the property. So there in the main, we have a try there. But here in the set, we just have the throw. It throws, so throw, it works like, I have this ball here, which is the problem. I'm gonna throw the ball to you.
Okay.
And you catch the ball. And who's catching the ball is main. Main is the one catching.
Okay.
So this one is throwing for somebody else to catch, and that's main.
And this will go to catch there.
Yes.
Okay.
And then it's up to main to decide, okay, I'm gonna ask again for a new value, or I'm gonna quit.
Got it. And set would be here.
Yeah, so it's not a set, it will be something like object dot name equals to whatever it is. At that point, this will run, and it may give an exception, it may not, depending on the rules that you have implemented there.
Okay, got it.
Okay? I don't know if it makes sense.
And why did we lose points here? Constructor without parameter didn't initialize any instance data.
Yeah, because the assignment was asking specifically to initialize all private fields.
Yeah, so I think what we did was, so I did not initialize it myself. So I actually prompted the user to enter the details, but it was there. So we were setting the values in the constructor, but it's just that we were not doing it hard-coded, we were taking it from the user.
If you want to open, I can give you more details there.
What was the name of the assignment? Sec004. I'm not sure if this would be it. Let me try. Gross salary? Assignment. What's in there?
I think that's the one. That's Java. It's a Java one.
Do you remember?
I think it's so employee. Go to the class here. I think it's employee, isn't it? So you see, employee here is not initializing any member. There's no members here. In the point there.
Is it this one we're talking about?
No.
Yeah.
Well, yeah. That's.
So what did they do here?
So if you scroll down there in the exercise, in the assignment, you're going to see that it's asking to initialize. So keep going down. Go down. So down a little bit more. Let me see. Scroll up a little bit. Let's see here. Keep going. Yeah, so one without parameters for initializing all the instance data members.
Oh, so this is because it is without parameters.
No, okay. So you're not following yet. Where's the constructor?
I got it. So we had to just
Here?
initialize it with any value.
I keep going down. I think it's all the way down.
There.
See, here, there's nothing here. So for each property, we should, the point is asking to initialize. But again, you did well there.
So it has to be like any random value.
Could be any random value. Could be something.
Oh, so we don't do that, and then we took it from the user.
Okay, that was it. Okay, awesome. Yep, be there. Okay, can I see it from here? Let me try the other way. Top.
It says that the interface just contain abstract methods.
The what?
The interface.
The interface. Okay. Which interface you mean? Okay?
Okay. He said that the interface can contain events, methods, and properties, but cannot contain files.
Fields, yeah. It cannot contain like private fields, yeah.
Private fields. But when I create property, it is implicitly creating like file fields.
Yeah, but not for an interface, because interface has no implementation. In the interface, you just define that I want a property called name, but you don't define the details of that property there. You have to have a class inherit from that interface that then will define how that property will behave. Even if it's a basic get and set, if it's auto-implemented, but it's not defined in the interface, it's defined, it's concrete in a class that inherits from the interface. The interface does not have any implementation. And when you have variables like private fields, it implies implementation, so yeah.
And how does it? Because when, for example, the abstract methods, you don't have a body yet. You just create the method.
Yes.
And you use, you inherit,
Abstract methods from abstract class or from interfaces?
When you create a class and you inherit of an interface,
Yep.
you are going to
Implement.
in this class.
Yes, whatever was defined in the interface.
And when you inherit an interface, you don't need to use override.
No, you don't.
But
You
if
don't.
you inherit an abstract, you need to.
Yes, you do. You do need.
And also, what about the properties? How can I implement the properties? Because the methods, for example, this abstract class, I
Yep.
use the override and implement the methods.
Yep.
And what about the properties of the interface? I call them.
You just call them. You just call the property. If it's an auto-implemented property, you just call the property like property string. No, sorry. Public string name, and maybe you have a get semicolon set if it's auto-implemented, or you expand them. You have a get with a body that returns the private field in a set. So you just, yes, you can. You just extend that. It's like, to be honest, it's not no different than a regular property. It's no different.
It's just useful when I like
What-
to decrease the code because I can use the same interface for a lot of classes.
Yes, and not only that, but when you use the same interface for many classes, you can combine. I don't know if you remember one of the videos that was combining different types of animals, and it was looping through all the animals. And if I call make noise from a cat, it's different from make noise from a dog. So what you can do with an interface is you can combine a collection of objects. All of them implement this interface, but they might be completely unrelated to each other. Like what we have, employee may inherit from iWorkable. An animal may inherit from iWorkable. So you could have potentially a collection of iWorkable. You could have employees, you could have animals. They don't have anything to do with each other, but they share iWorkable. So we could loop through that collection and call do work. Because all of them, even though the work of employee has nothing to do with the work of the animal, but you could call do work from both of them. Okay?
In this code here, say I need to call the method here because for example here I use the interface I work about for the employee and for the animal, but for example here in the employee I just call the method
Yeah,
work.
you define the method work, yes.
But why here I need to call, for example, here in the abstract class, I am not going to define this method.
Okay.
But I need to call always.
Yes.
So I am not going to define the method.
Correct, because yes, it's necessary, because you have two options. If you are in an abstract class and you inherit from the interface, you can either implement the methods of that interface by writing the entire body and not using the abstract keyword, or you can just use the abstract. Yes, so it can be either concrete or abstract. If it's abstract, then any class that inherits from employee will have to implement, in our case here, do work.
And it is not possible just inheritance of the workable.
Yep.
Of the interface are workable, and
Not
in this
mention
case,
that.
I am not going. Yeah, not mention it, and inherit dog of animal.
And then mention
it
there.
doesn't mean, yeah, doesn't mean that as animal inheritance of a workable, it is not supposed that dog is also going to have.
I get it. It's just not the way it works. You have to define in the animal, even though it's an abstract class, but you have to say, either you implement workable, do work, is that work?
A workable.
Work. So either you implement work or you say, I don't want to implement now, I'm going to say that this is abstract, I'm going to let my children, whoever inherits from me, to do the implementation.
I need to do it with all the content of interface.
Yes.
The property, the
Yes,
method,
correct. If the interface is very complex, we may have a lot of code there. But yes, that's correct.
Okay, thank you.
Okay?
And just about this one, the call state. What does it mean, the call
Call,
state?
call stack. Okay, call stack. I'm gonna show what that is. But let's say you have main, and you have another method, and main call this method, and a problem happens in the second method. In let's say in our case here, check temperature has a problem there. So the stack is, what is the order of who called who? Oh, so we have check temperature, which was called by main. So this is the stack. The stack is who called what. You may have a method that calls a second method, that calls a third method, that calls a fourth method. So all of them, they become a stack. Who's calling who. So the application keeps track of who called who. So in the case of an exception, it throws to the other guy that called that method.
Means they call the exception.
Yeah. So we have a stack, like a list of methods. Who called who? In this, because again, you can have a sequence of this method called this method, which called this method, which called this method.
Okay, yeah.
So
you go wrong, go for the
goes backwards. So if something goes wrong in the very last one, it throws the ball up. Then the next one caught the ball. There's a try there, yes or no. If there's no try, it throws to the other guy. If there's no try, it throws to the other guy until you get to the last one. If the last one doesn't catch, guess what?
Go to the main.
If main is the last one. If the last one doesn't catch, what happens?
Close. Go.
An error. The application crashes. Okay?
So they try to do several attempts.
They go all the way up in the stack. Whoever catches, hopefully someone in the stack will catch. If nobody catches, the application crashes.
The index, they try to find which one match in that section, right?
They try to find if there's a try. If there's a try anywhere that catches that exception. So it's not all tries. It's a try that catches that exception. If it finds, great, it's handled there. But if it doesn't, it keeps throwing back and back.
This is the ones that we did the last class. That
Yes,
several
very
ones.
similar. Yeah.
That thing is called call stack.
Well, call stack is really this list of which method call which method, which call which method. This is the stack. Okay, this is the call stack. I'm calling this method, which call this method, which call this method.
And always I need to use the keyword throw. Because
Throw?
for example, I can make, for example, the division by 0 and return like error and come back to the main. And here the result is error, then it's catch automatically, or always I need to use throw.
Well, you could let it go, and this I don't know what's trying to prove here, because here what it's doing is, if y is equals to 0, it's throwing a division by 0. This here would throw anyway a division by 0. So again, even if you take this out, this would still throw an exception. An exception can either happen naturally, like what you see here without throwing, or we can check like what is checking there, and we throw manually. We use the keyword throw, and that's what I'll be doing now.
Is there an advantage or do it?
It's more of, because here's the thing, there might be situations that the code will not give an exception naturally. I'll give an example. If you have a method that accepts a parameter which is an integer, and you don't want negative numbers. If someone sends a negative number, I will throw an exception. Your code will throw an exception. Even though it's not a natural exception, but you don't accept that in your code because it's not a valid argument. So you want to throw an exception yourself. You don't want to wait for the code to throw an exception because the code will not care if they send minus. That's what we're going to do in this exercise. Okay? No problem. What is that?
I just accept like a, yeah, what is like a call to action? Okay, it's call to action.
We're gonna see it here. Okay, so let's get going with this one. Okay, now, before I start, is there anyone that wants to have a code makeover? What is a code makeover? Maybe you want to submit your code. I'm going to use your code as a starting point. And I'm going to mention, okay, this could be done differently, or we could use this like this. You don't even need to identify yourselves. It's on Padlet. If you don't want to put your name, that's fine. But you have the option to put your code there, to put the code for this exercise. And again, I'll be checking it out. I'll be giving suggestions. And again, you can just, if you want to do that, you can quietly go, type there so I don't see that you are typing. Okay? So again, I'll leave it up to you. I can do my own code, but if you want to, have me to have a look at your code and assess it as we go along, we can do that as well. So I'll give a second for you to think about, consider the pros and cons, and hopefully someone gives me the code. Okay, don't put in the title, though, because the title will make this a little bit unreadable. Let's put it this way, okay? So if you add, put just code in the title and then add the code in the bottom of the message on Padlet. Okay. Okay. God, the only thing I think that this is not this exercise, because this exercise does not have an array. Okay, so we have one here, okay. Okay, let's use this as a starting point. Okay, I'm just going to copy from here. And I'm just going to put in a text editor because it's a little bit better to visualize. Okay, so let's start with the name here. So let's just start reading here. So argument exception is an existing exception class. No, it's given to us. We don't need to create it. It's already available. And it's used whenever, for instance, you send a parameter to a method, and that parameter is outside the range of acceptable parameters for that method, okay? So you can throw an exception that says argument exception. It's outside of the valid parameters, let's put it this way, or valid arguments. So create an application called swimming water temperature. So let's create that. New project. So you're going to find the console application. Here's the name, swimming temperature. Okay. Okay. Okay, let me check here the codes. Okay, so the codes that someone posted has a console, right? So it's asking for the temperature. It's declaring a temperature which is an integer. Good. And it has an option that says string option equals to y. I'm gonna copy that. I'll be using bits and bits here. So again, enter the temperature value. I'm just gonna modify a few little details, nothing much here. And then it's gonna read the temperature, great. Now, yes, convert.int32 is one of the many different ways to convert a string to an integer, okay? However, we can use, actually, let me ask you this. What will happen if I type, a name, in this case here? If it's waiting for me to enter something and I type a name, what will happen? You're gonna have a problem, isn't it? So, is there a way that we can convert to an integer, but if there is a problem, it does not break the application? What could be the one? We could use try parse. Try parse, differently from convert and different from parse, which will break the code if you put something that is not a valid integer. Try parse will attempt to convert. If it's able to, great. If it's not able to, it's not going to fail. It just return a false. So instead of using convert.toInt32, let's use try parse. And we can use it like this. We can say int.tryParse. The first parameter is the read. We're going to read from the console, so we're going to use this line here. And the second parameter is the output parameter that will store the temperature value if the conversion works fine. So I'm going to say that the output and out parameter is temperature. And then I'm just going to get rid of this part here. So I'm going to get rid of the convert to int32. I'm just going to leave this. Okay? A minor modification, I just wanted to ask to practice using try parse as well. Okay? Again, try parse will not trigger an exception no matter what you type. Because if it's able to convert, it's going to do it, and it's going to return true. Otherwise, it's not going to return, otherwise it will return false, and temperature becomes 0, okay? So if it's able to convert, temperature will hold the converted value. If it's not able to convert, temperature becomes 0, and it just moves on. Okay. So let's just finish understanding the question here, the exercise. So create an application named swim water temperature containing a variable that can hold the temperature expressed in degrees Fahrenheit. So we have the variable here, temperature. within the class, create a method that accepts a parameter for a water temperature. So you're going to create this method, and this method works like this. If the temperature is between 70 and 85 degrees, that's comfortable, and the method will return true. If it's outside of either lower than 70 but higher than 85 or higher than 85, it will return false because it's not comfortable. However, if it goes too much beyond the extremes, and what are the extremes? 32 degrees or above 212 degrees. So if it's either below 32 or above 212, it becomes invalid. So we throw an exception. So again, the method will return true, false, or it will throw an exception. Okay? Let's see what the code that was provided is doing there. So we have check water temperature, great. It's accepting the temperature, good as well. And everything is good here. I like what's doing here. So let's copy this here to the code, and let's break it down. So check water temperature, that's fine. Parameter is fine. There's a local variable here called bcheck. Okay, that's fine as well. It's a Boolean that will store the value, whether it's true or false. And then it checks if the temperature is above 70, including 70, and below 85, including 85, B is equals to true. That's fine, this is enough. To make things a little bit more clear, again, I'm not changing because I think it's wrong. It's right, but I'm just gonna make it, let's put it this way, more right, more correct, or more clear, okay? I could do something like this. First of all, because there's just one line of code, I can get rid of these, okay? And just to make it absolutely clear, in case it's not that, I'm gonna put an else here. And I know, I get it. It's already set to false here. I don't have to set false again. But I just want to make it super duper clear that if it's not within that, it will be false. Again, would it be necessary? Not really, because it's been set to false already here. But sometimes we do a little minor thing like that just to make the codes a little bit clear. Now, in a test, will I mark this down? Will I mark this as wrong? No, I would not. I would have not marked that as wrong. I'm just talking about what would be best practice, you know, what would be a little bit more clear. What is it complaining here about? Oh, I think I know. I think that it's missing here. Let's see. A few parentheses, maybe. Let's see. Okay, anyone? What's the deal here? Else starts a statement. Oh, I see. Okay. Got it. Okay, so there is an else. Okay, so here. I have a slight modification I'll do here. And so I'm going to keep the if else, but here, let's have a look at this. I could do just this. If temperature is below 32 or above 212, then throw the exception, okay? But let me ask you this. Not only which one, but why? Would it be better to keep this block of codes after this test or before this test? And why? Yes?
Before the test, because you have it afterwards, and the code is not within comfortable temperatures, but it's
then it would trigger the else statement before checking to see if it's too hot or too cold.
Yeah, so correct. So if we put this before, if the temperature is already invalid, tell me right away that it's invalid. Don't even try to do anything else after that, okay? Because here, if it's, let's say, 32, it means that it's gonna be check is gonna be false. Yeah, I get it, but it's gonna throw an exception anyway. So how about you just throw the exception before check for anything? So we could potentially just move. And again, what I'm doing will not invalidate what the code that was put here before. I'm just giving you a better alternative. But the code that I pasted here initially was correct, okay? Now, I can make it like this. Because it's just one line of code, I can just keep one line there. And perfect, I think this is good. Returns be check. One quick note, it's static because it's gonna be used inside main, which is also static, okay? So a static method can only call other static methods, unless you initialize an object of a class. But in this case, again, if I get rid of static and try to use it inside of here, we won't be able to do that. And whether it's public or private, right now, because there is no accessor, it means that it is. Internal is for classes, okay? Here it means that it is the most restricted one, private. Okay, so I could say private or not, that's fine. Okay, so I think that our method is okay there. Let's have a look back at the main. So let's see what this code is doing. Okay, so this code is going here through a loop. Let's just copy the loop part. So here is the loop. I'm not going to add the try for now. I'm just going to say this. Okay. Okay, so what I'm getting from the code is this. Well, first is this. This is forcing an infinite loop, correct? Yeah, okay. It will be infinite. I also think that there is a better way to handle that, but I'm going to leave it for now. And then what it's doing is, it's reading the option. Do you want to continue to check? Yes or no? Great, that's fine. So if I put in of no, it breaks the loop. Good. Does it work? Yes, it works. Can it be, I don't know, different? It can always be different, and I'm going to give my spin to it, okay? Instead of having two questions, which is, one is, do you want to continue? Yes or no? And then ask for the temperature. I can put both questions at the same time. If they use, let's say, types 999 or another magic number that you may have, then we get out of the loop. So we could potentially change this a little bit and say, with the intention of not having, actually we have to change a few things here, but I'll do that in a second. Let's start by creating our non-magic number. I'm going to say const int stop equals to 999. So as I go through the loop, if the user types 999, we're going to exit the loop, okay? So I'm going to say here, where does it start? Okay, temperature. So I'm going to say, if actually while, by the way, a quick note. If you see yourself having to do something like this, 1 equals to 1, something that it's obvious true, there's something that could be done a little bit better there, because it does not make sense to test that. Because it will be, I could just say this, while true. So it will just loop through. So again, this kind of, I'd call this artificial way of adding a loop. Well, it's a bit artificial. Anyway, it usually means that there's a better way to do that. And here is what I think it's a better way. Again, I would not have marked this down, but I'm just showing you what I would think it's a more correct approach here. So if I say while temperature different, then stop. So we just ask one question. We're going to say, okay, so here it's checking the temperature. Great. If it's comfortable, shows this message. If it's not, shows this message. Great, this is fine. Then, again, instead of asking if the user wants to continue, I'm just going to ask for the user to type the new temperature. So I can get rid of this, and I can just ask for the temperature again. Enter the temperature value. And it keeps doing that. Okay? Now we can get rid of this guy as well. So let's get rid of it. Okay, it's already 5:30. So let's have 5 minutes before we close this demonstration. In 5 minutes, we come back. I close this one, and we'll jump to some training quizzes, okay? 5 minutes. Yes, I'll drop by. Let me just put my timer there.
So how users know, like if we are gonna type 999, then
Good point. I'll address that once you come back, okay? What's up?
In this, I'm getting this thing, except this exception is not handled.
Yeah. Who's handling that? Where are you calling? Yeah, throwing is throwing. Who's calling that? Where are you calling?
This method, square.
Yes. Where are you calling it from?
Here.
Yeah. Is it inside a try?
Yes.
Where's the try?
Oh no.
Okay, that's it.
There's a friend who's in this class, Dinesh.
Yep.
He's not present here.
Okay.
And he's asking if he can take the quiz remotely.
Okay, that's fine. That's fine. Just tell him to be close to his computer by. So far, I think that we're gonna do that as the last thing of the class. So by 8 o'clock. Okay.
So are you going to email it to him, or are just?
Just tell him to be available, to be there, because it will be active there. 8 o'clock to 8:20.
8 to 8:20.
Yep.
Thank you.
So now we can like work on this at the same time. Right, so so which parts do you want to do here? Yeah. It's populated.
Eu achei que sempre agora eu tirei e completamente. Botei isso, botei no pai. Botei no pai deu
Okay, so we have to take So if we look at, okay, so it doesn't take any parameters, right? So we need to first read all the file.
Okay, so let's carry on. Let's keep going. Okay, so just to answer your question, okay? We can just do something like this. I was asked, how will the user know that they can type 999 to quit? Well, we can just tell the person. So we can say, oh, this is not, yeah, so we can say enter the temperature or 999 to exit, okay? This one here, I'll put right line. I'll have right line here. Okay, so a few things that I want to fix here. Look, we have a lot of what here? We have a lot of magic numbers, okay? So let's fix them. So let's practice what we preach. So let's use some constants here. So const, let's see, int low equals to the very low, like 32. Then we have low comfortable, which is 70. High and high comfortable. High is the 212 and high comfortable is the 85. And then we just replace this accordingly. If something like this would be used in more places on the code, instead of declaring here inside the method, you can declare inside the class, okay? So we have high. And we have high comfortable. Okay, so we took them away. Now, one thing here is that I did not put what yet. Actually, before that, let's see how this is behaving. Let's run this. Let's give it a try here. So let's go with 71. Temperature is comfortable. Let's make it a little bit higher, 87. Temperature is not comfortable. Great, so we have the range there. Let's make it lower. Let's say 45. Temperature is not comfortable, but if it's in between, let's say 75. It's comfortable. Now let's make it extreme, outside of those extreme numbers, like less than 32. So let's make it 24 here. So now we have unhandled exception. So it's saying that we did not handle the exception. We throw the exception here. If I can find the code, yeah. So we throw the exception, but nobody's catching that. You can think about throwing and try and throw and try as like this method is throwing a ball to somebody else for somebody else to catch. It's throwing this exception, somebody else needs to catch that. It does not make too much sense to have a try block inside of where I'm throwing. Okay? You can think about you throw to someone else. Usually you don't throw to yourself. When I say yourself or someone else, I mean yourself as a method, someone else another method that might be calling me. Okay? So again, when you throw, you usually don't throw to yourself. You throw to somebody else to catch that. Okay? So we should put try, but it's about not whether we should or should not, but where. Where should we put try? Here's the question. Where should we put try? In the main, okay? So the code here that I have is doing that. It's trying in the main. So let's use this structure. The same structure here. Let's do this. So we have try at the very top, outside of while. So let's do this, the same thing here. So we have try here, and we're going to close it here, and we're going to have a catch, which is also written here. Let's start here, and then we may change that, okay? But let's start outside. Great. So we have argument exception, E, awesome. It's showing a message here. Sorry, it's showing the name of the error. It's showing the message of the error. It's doing that with this style. That's okay, all good. Let's try this. Let's try the try. So regular numbers here, message is okay, 70 is okay. Let's go all the way up to 34. Great. Argument exception, the freezing and boiling points of the water. So again, whatever message was given when we created the exception. Great, awesome. Now, this is correct. This is working fine. But look at this. It's not going to ask me. It's not going to give me another chance. When I hit enter, it's going to quit. So the exercise, it just said that you should keep asking the question. Now, it's not clear whether or not you should keep asking, even after an exception. But let's assume for a second that, hey, what if I want to throw the exception and I want to keep asking the question? I want to know that there is an exception, but I don't want to stop there. I want to keep running through the question. So looking at this code here, what should I do to handle the exception and to keep asking for a new temperature? What should I do? What should I change? While? while should be outside the try. Let's try that. Let's do that. Okay, so I'm just going to do a copy and paste here. I'm going to remove while, put it outside, and put try inside, okay? So I'm going to just do this. Control X. I'm going to put this at the top. And then I'm going to move try inside the while. Okay? And I'm going to move this entire code inside try. Just to recap what I did again. So instead of while being inside of try, now we have try inside of while. Okay? So does that make more sense now? Let's give it a try. Talking about try. Let's see. Let's do a very low temperature here and see how it goes. Something going wrong there? What do we have there?
So when you're asking to stop, you need to put the while there, and then because it's working fine.
So we are in an infinite loop. We got ourselves.
I'm not asking for it again.
Okay, so how would we fix this infinite loop? Because here's what it's doing. It checks the temperature. Temperature is invalid, throws the exception. As soon as it throws the exception, it jumps to the catch, and it goes up again. And the temperature is still the same one. It goes down, throws another exception, goes down to catch, and goes up. So it's doing that indefinitely. So we should, what?
We need to get the temperature again.
Again, so what should we change then?
After catch, just take the temperature again.
So maybe we should move those lines.
Yes, down there.
Actually, let's move it down because up here, we already asked for the very first time here. Okay? So we're going to do, let's try this. Let's put this outside. So it's still inside the loop, but it's outside the try block. Okay? Let's see if this makes sense. Okay, so again, let's try the conventional ones. Comfortable, uncomfortable, not comfortable, a very low one, 20. Great, so argument exception, the freezing boiling and boiling points of water, and it asks again. So the exception was thrown, was caught, but it gave me the opportunity to keep asking. Okay, so I can keep asking, I can go all the way up, and seems to be fine now. Let's see what else we have here. Okay. 999. Great. Just one more thing here to mention. Remember that we have a block that is optional called finally. What is it finally? Again, anyone? No matter what, it will always run. So is there anything here that no matter what, it should always run? The block at the bottom? So it would be the same thing, to be honest, in this case, because we have a very simple case here. But we could put something like this. You could say finally. And we could put this inside finally. It will behave very much the same. It will always run. And again, it's 5 and 21. Again, no difference here, but it's just one situation that we could use the finally block. Again, finally block very much used when we are dealing with files and we need to close a file before everything is done. Okay, so again, very useful when we need to close resources that might be open even after an exception. Okay. Okay, great. I'm going to copy this entire code. I'm going to share on Padlet so you can have a reference there. I will also, as you go through the other exercises, you have exercise 3 and 4. We may not be doing them today, but you can take them home. And you're going to have plenty of time next week to play with them. Okay. So, again, hopefully this was relevant to whoever posted the code, okay? So, yeah. I don't see more questions here, I don't see anything else. Great. Again, any questions about this particular example? This particular exercise? Or are we comfortable with exceptions? Okay, so here's what we're going to do next. Let's do what I had mentioned right after our exercise. This was the demonstration. If we have time, you can start exercise 3, but for now, we're going to do three quizzes on exceptions that will help you out to get ready for quiz 04. Okay, so I'll bring near pods. So if you want to load, you have a question? Yep, go ahead.
So if there is a mismatch in the data type, so for example, I entered integer and what asked was a string, or maybe I entered a string, but what asked was a number.
So what do you think will happen here?
0.
Yep, 0 where? In the try parse, because it won't be able to convert, and then temperature becomes the default value of integers. Yeah, it's either that. I'm quite sure it becomes 0. I was uncertain, but I think I've tried that. It becomes 0. So again, if it's invalid, it becomes 0, and we have try parse. That's why actually here's the thing. We should convert this to try parse as well, because I only converted the one up there. So we should do the same thing here.
But is there any way that we can get an exception, like a message that we get in other exceptions?
Okay, let's talk about that. Okay, so I'm just going to make this minor change there. So here's the thing. Try parse is a method that returns what? It returns true or false. So you can say if try parse, you can do an if you want to tell the user that, hey, you typed something wrong here, you may want to do an if statement. Okay? No problem. Okay, so okay, so let's do this warm-up here. It's a simple exercise, but it's a good one to get us started. So 3 quick questions about the topic. Okay, I think that's, let me see here. Okay. Get done, get your answers, so we can check them. Okay, let's have a look. So, consider the following try block. If x starts with 15, what is the value of a when this code completes? So what is it? So x is 15, okay? So a starts as 99, then x is 15 is greater than 10, an exception gets thrown. When an exception throws, we still run this line and this line, correct? No, we don't, okay? So when this exception throws, it goes out of the try and continues right here. So those two lines, they no longer run, okay? So A stays as 99, okay? So when you have an exception, the rest of the code does not run. Now, I'm going to tell you this, the rest that is inside the try, okay? So this is, jumps and it goes to a catch or goes to whatever is after here, okay? So it's 99. Again, ask the question if you did not understand what I just said, okay? Next here, consider the following catch blocks. We have two catches. Variable B starts with 0, and a divide by 0 exception occurs in the try. So we have a try here, divide by 0 occurs there. Then what? What is the value of B after this block right here? 1. So it's 0, the catch divide by 0 happens, plus 1. This does not run, just one catch runs, okay? So it becomes 1, B becomes 1, B becomes 1. Consider the following catch blocks. Now we have two catch blocks and a finally. Variable C has been initialized as 0, index out of range exception occurs, right here in the try. After here, what is the value of C? Index out of range, so C plus C, C becomes 1. Finally, always run, okay? So we have plus 1 becomes 2, okay? Make sense? Great. How did we do here? Okay, so again, I hope that the people in the reds, they got it right. You know, again, if you have a question there, please ask. Let's give another try here with a second set. We're going to do 3 of them. So second set here. Here's the other one. Okay, I'm going to take a quick attendance here. So Andrea, Anjali, Chloe, David, Dharmik, Dinesh, Igor, Elgin, Eric, George, Hao, Hong Viet, Jayanth, Jessica, Karamvir, Kenneth, Krupa Ben, Michael, Osman, Philip, Rafsan, Raul, Rafael, Robert, Sinran, Siranjit, Sonap, Thimin, Walid, Zian,
Can I check my answers if it's wrong or right?
if there is a way.
No, if it's wrong or right.
I don't think that there is a way when we do it online. Yeah, I've checked there in the tool. It doesn't, only when I have another option that is a self-paced, student-driven, but this option doesn't tell you which one you did wrong. But as we go through, hopefully you're gonna remember which one you marked down, okay? It's not because I don't want to, it's just because I think that the tool, the way we use it, it does give this option. I don't know why, to be quite honest.
Tolerante parece muito da hora.
Eu pensei, vou buscando se alguma coisa tem justificado do carro, aí porque o carro leva porrada.
Okay, so pretty much everybody did already, okay? Okay, so let's see. In C#, all exceptions are objects that are members of the class or one of its derived classes. Which one? Exception. Exception is the parent of all exceptions, okay? Now, all of those application exceptions, system exceptions, runtime exceptions, they either come straight from exception or they come from one exception class that comes from exception, okay? Exception is the parent of all exceptions. Except exception. Except itself. Oh, of course. Anyway, okay, this is a good one. I want to hear you. Errors you discover when compiling a program are considered exceptions? That's correct. They are not. If I say here in the code, if I do something like something to break the code, and I try to compile or to run, and I get this error, this is not an exception. This is a compilation error. There is something wrong with your code there. Okay? So it's false. Okay, next one here. Ta-da, represents the degree to which a system is resilient to stress and able to maintain correct functioning. What is stress? Stress is, it's running out of memory, or it's running out of resources, or, which one? The last one, robustness. Sometimes I have to stop and think which one is that, because fault tolerance is also, fault tolerance is when something goes wrong and the application is able to continue working even though something went wrong. That's the whole point of having a try block, okay? So this is robustness. When you write a block of code in which something can go wrong, you can place the code in a try block. See how easy it is? It's very easy. The quiz is very, very easy. Awesome. Okay, last one, I promise. Okay, here's the last one. Okay. Okay, so let's give this a try. So 4 last questions here. Okay, so those questions, they will involve looking at the methods and properties of exceptions. So the exception class overrides this thing to provide a descriptive error message so a user can receive precise information about the nature of any exception that is thrown. What is it that they... Okay, so here's the thing. Let's read this properly. So exception comes from which class? No, exception. I'm talking about the exception class. The parent of all exceptions. It comes from where? From objects. Okay? So the question says exception class overrides. So if it overrides something that comes from objects. Two-string methods, okay? It has a message, but message is not a method. Message is a property, okay? Here we have, okay, the exception class contains a read-only property named that contains useful information about an exception. It's a read-only property message. I think that stack, actually let's try this. Here in our codes, in the exception, let's change a little bit our exception to say something like this. We're going to say console, right line, sorry, not like this. Okay, if I can type. Okay, so I'm going to say error details, and I'm going to say, just want to show the differences there. So string, I'm going to say e.toString. Let's read each one. Let's do a message. And let's do a stack trace. So message and stack trace. Now let's just put some space in here because otherwise this will come all together and it will be hard for us to visualize this. So just going to create a very distinct block. Of course, this is I'm just going to make a very distinct block here so you can really see the difference from one to the other one. Just give some space in there. So I'm going to print out all of them. Let's go for the exception. Here the exception will be if I put something too high. Look, we have the error to string. It has this whole thing to string. Error message, it has just one line of message, just this line. And then stack trace, it has this final part. So in a way, toString is the more complete one. It shows the message, it shows the stack. Error message only shows a simple, usually user-friendly message. It's just one single line. And stack trace, it only shows. What is stack trace? Stack trace is showing which method called which method in which line is the problem. Look at this. It shows that the problem was on check temperature in file so-and-so, program.cs, line 66. So it shows all the nitty-gritty details. To be honest, if I'm a user of an application, which one of those three should I present to him or her? Just message. Now, if I'm a developer and I need to look at the logs of the system to see the details, which one should I get? Maybe toString, stack trace, but as a developer, this error message here will not be very useful, okay? So you can see that toString is a combination of message plus stack trace, okay? Anyway, so in our case here, read-only property that contains user information about the exception. Well, stack trace is also a property. Is it read-only? Let's see here. It should be. Yeah, it's read-only. Message is read-only. I'll be on the fence between both of them. Message will be short and sweet. Stack trace contains user information about the exception. Actually, this will clarify. This will make sense. So message does not give details about the exception. It gives a general message, a user-friendly message. toString, why it's not toString here? Because it's not a property. It's a method. Then we are left with stack trace. Okay, so it's stack trace. Does it make sense, or I went too fast here? Okay, next one. We just saw that, okay? Try parse, okay? The other ones, they do not exist. And this is a good question for whom? For Google. You can ask Google, it should give that answer there. I mean, I didn't mention this throughout, but yes, it's IO exception. It's not file exception, okay? These, they don't exist. IO exception is the only one it's the input-output, okay? Related to files. Anyway, that's it. I have a question for you. Would you rather question. Would you rather have the quiz for in the beginning of our segment or at the end? So either in 15 minutes or at 8 o'clock in our last 20 minutes? Now or later? Now? Good, okay. So I think that's almost everybody wants now. So. Okay. Okay, that's fine. So let's have a break, 15 minutes, our intermission. As we come back from our intermission, we have the bloody quiz already. It's not bloody, by the way.